the root test. So we're going to let the series n equal 1 to infinity of an be a series. Then the first part of the root test, if the limit as n goes to infinity of the nth root of the absolute value of this sequence here, that right in there, of this whole series, is equal to L, some number that's less than 1, then what? Then the series n equal 1 to infinity, a sub n converges absolutely. Very similar to the ratio test. Okay. The second part, if the limit as n goes to infinity of the nth root of a absolute value of an is equal to L, and it's greater than 1, okay, then the series n equal 1 to infinity of an diverges. Okay, so greater than 1, we diverge. Less than 1, we converge absolutely. And if the limit as n goes to infinity of the nth root of the absolute value of an equals L, which is 1, then the test fails. Okay? So if it equals 1, whenever I take that nth limit, the nth root, and then take the limit for the root test, then the test is no good, and we're just stuck. Okay. So what's going on here? Basically, what's going on is I'm taking this limit. So the limit as n goes to infinity of the nth root of absolute value of an equal to L. Now, what can I do to get rid of that nth root? To get rid of the nth root, all I have to do is raise it to the n on both sides, and that's going to get me absolute value an equals L to the n. It's basically a geometric for sufficiently large n. So as n gets sufficiently large, this looks like some type of geometric going on here. So it's very connected with the ratio test, except instead of doing ratio of the n plus 1 over the nth term, we're taking the nth root of some series. So this series is very helpful if I see something, I've got powers to the n, I'm trying to get rid of those powers to the n. So 1 to infinity, 1 over 2 to the n times 3 plus 1 over n raised to the n. Okay? So looking here, I've got this power to the n here. I can rewrite this. This series can be rewritten n equal 1 to infinity. Everything in here raised to that n power. What's up there in the numerator? I have 3 plus 1 over n. Divided by the denominator, I have that 2 there. Okay? So my an, my absolute value of an is equal to 3 plus 1 over n divided by 2, all raised to the n. We can drop the absolute values here because n is greater than or equal to 1. So that's definitely positive. Now I want to run the root test. So the root test says I take the limit as n goes to infinity of the nth root of 3 plus 1 over n to the 2. Okay, divided by 2, all raised to the n. Now what happens when I take the nth root of something raised to the n power? The nth root of something is like x to the 1 over n. So if that x in here already has an n, then power to a power, I multiply exponent. So that's n over 1 times 1 over n, which gets you 1. So that ends up canceling out. So really what we're left with is the limit as n goes to infinity of what? Well, all that's left is this inside here, 3 plus 1 over n divided by 2. And when I take this limit, nothing happens to the 3 and the 2. But the 1 over n, when I take the limit as n goes to infinity, this is going to end up dropping. That's going to go to 0. Okay? So I get 3 over 2. Now, what do I know? 3 over 2 is greater than 1. So what does this tell me? By the ratio test, by the root test, the series n equal 1 to infinity, 1 over 2 to the n, 3 plus 1 over n to the n, diverges since this limit right here equals 3/2, which is greater than 1. Okay? So that right there is my answer. So by the root test. Okay? So let's try one more root test problem just to make sure we're good to go. Example, series n equal 1 to infinity, n times negative 1 to the n over 2 to the n, okay? So let's look at absolute value of an. This is equal to the absolute value of n, negative 1 to the n over 2 to the n. What does the absolute value do to this negative 1 to the n? Well, it just makes it go away. It turns into 1, right? 1 to the n, which is just 1. And so I get n over 2 to the n, okay? So now I'm going to take the limit as n goes to infinity of what? The nth root of n over 2 to the n. Now this one is interesting because the nth root gets rid of that n in the denominator but not the numerator. Remember, this is the same as the limit as n goes to infinity of n over 2 to the n raised to the 1 over n. Okay, you see that? There's only one of those inside. Remember our little trick, the rider and the horsey. Okay, the rider goes on top and the horsey goes underneath, and the horsey's out in the barn and the rider is in the house, right? Okay, so this thing right here, what's going to happen? What's going to happen here? Well, when I use my power exponent rules, I get n to the 1 over n divided by n, or 2 to the n raised to the 1 over n. Those cancel, so I just get 2. So this becomes limit as n goes to infinity of 1/2 and then n to the 1 over n. Now this 1/2 here, this 1/2 can come out front. And so I get 1/2 limit as n goes to infinity of n to the 1 over n. This form is what? This form is infinity to the 0. Uh-oh, this form is indeterminate. So to solve this problem, we're going to have to go back to something that we learned a long time ago, and hopefully we remember that little trick. To get this out of the exponent, what I do is I set it equal to something. I'm going to say just call it y. So n to the 1 over n equals y. Now what I'm going to do is natural log both sides. And when I natural log both sides, this becomes 1 over n times ln n. Okay? So this becomes natural log n divided by n. All right, so now instead of looking at the limit, I'm going to look at the natural log of the limit. And then to get back to my answer, I'll have to e it. Okay? So let's work through this, see if we can't figure this out. So I've got the limit as n goes to infinity of ln n over n. This is of the form infinity over infinity, so I can L'Hopital. So this is limit as n goes to infinity of 1 over n divided by 1. Where did that come from? The derivative of ln n is 1 over n. The derivative of n is 1. Okay? So now my work is pretty much finished. This is 0 over 1, which is 0. Okay? So what does that tell me? When I take the limit as n goes to infinity of the natural log of that limit, I get 0. So what do I need to do? I need to e to get back to just the limit. If I e both sides, e to the 0 is equal to 1. So that tells me that the limit as n goes to infinity of n to the 1 over n is equal to 1. Okay? Wow. Now, we're not done because that limit is multiplied. So this limit right here that we just found is multiplied by 1/2, right? So this is 1/2 of that. So 1/2 times that, that gives me 1/2. Now 1/2 is less than 1. Okay, so what do I have here? Just to summarize, the limit as n goes to infinity of the nth root of a to the n is equal to 1/2, which is less than 1. So by the root test, the series n equal 1 to infinity of what? -1 to the n over 2 to the n converges. Okay? So not only does that converge, it converges absolutely, since series n equal 1 to infinity of n over 2 to the n converges by root test. Okay? All right, guys. So the root test, not only does it tell us that a series converges, it also tells us that the series converges absolutely. That's all we're saying here. Okay, so if L is less than 1, which our L was 1/2 there, it converges absolutely. I think the other one we found L to be like 3 over 2, and then that thing diverged for us. All right, good luck as you're working through the ratio and root test.